Hello everyone, welcome to Vault Zero to Hero series. Let me ask you something. Where do you store your password, API keys, or database credentials? Is it in your code, or it is in environmental variables, or maybe some config files? Now, imagine this. Someone gets access to your repo, or your server, or even your logs too. All your secrets are exposed. This is exactly the problem where we are resolving in this series. So, by the end of this series, you will be able to secure your application secrets properly and controlled who can access them and even automate secret rotation in production. So, what is Vault? So why exactly we need to learn about Vault? So there are multiple keys without Vault as well. So we have different options to store our secrets. Why exactly Vault needs? Vault is a tool that helps you securely store and manage the secrets. That secrets can be API keys, database passwords, token, and certificates. So it's a basically anything which we can store in sensitively. So here again one more question you can ask me that so why exactly Vault? As I asked you like before, why can't the another resources which we were providing through the cloud insights something like KMS or caring in the GCP side. So there are the cases where we can choose apart from the cloud provider key services, key services. Firstly, Vault is a centralized secret management system which can have the access to the multi-cloud environment. It can provide the multi-cloud plugins to install over there. And secondly, we can have the dynamic secret creation, which can be provided as a temporary credential secrets based on the runtime or based on the demand. So, which does not have the capability of providing dynamic secrets through this cloud providers. Maybe we can see it as like KMS or something through the Google Cloud or something from this Azure as well. So if it is comes like let me show you visually like what you are seeing on the screen. So that's exactly we are gonna discuss today. So firstly, see without Vault, we were directly accessing the application secrets through the API keys or database passwords or token and certificates. This and all we were storing either directly through the code which is hard coded or we were storing it in the environment or we were storing it in config. So suppose if suppose if the user who is having the access to this, maybe the config map or maybe with the environmental server or maybe with the code repo access, they can easily get access of these entire data. So which is having high risk to expose outside of this. So then with Vault, we can achieve or we can overcome that by having the structured architecture of storing the secrets in a proper way. First, we have an application. So generally, we are not directly going to store the secrets in config map or environment variables are directly hard coded there. Instead of that, we were involving HashiCorp Vault here inside this. So, first application will talk to Vault with the method of any authentications where it can be OIDC or it can be Kubernetes or it can be app role. With that, HashiCorp Vault will authenticate the user, who is he and what access he has. Then, based on the request which has been given to this user, that will be go to the backend for the verification steps, which will be authorization. Authorization is nothing but the checking capability of the user, particularly whether he is having to fetch the secrets from the vault, particularly onto this particular secrets path or not. And here it comes. Then we were attaching the policy to exactly access with the fine grained and access controlled secrets path where the user not authorized to any of the other secrets were stored in the HashiCorp. This is how exactly Vault will works. So, as a summarization, I could say this application will try to hit the HashiCorp Vault API with the proper authentication method, which has been assigned or given to this application. That user in the backend, HashiCorp Vault will verifies the authorization or capabilities of the user, particularly having to the particular secrets. Then, if these are valid, then HashiCorp Vault will retrieve or generate the secrets to the application. So, this is more secure and more reliable and more it has the scope of flexibility and as well as the scalability as well. So, we have to maintain the HashiCorp Vault in that position. So, as I said, it has the capability of centralization, it has the access control, and it is the process of automation, which is like auto rotating the secrets and leases, and it can be auditable. So here, the main motive or the main achievement we can see here is through Vault, we can easily or we can audit the logs for the troubleshooting purpose, who accessed at what time at what secret they had it. So this is about exactly Vault, how it looks like. And we can like I can explain you this. The core concepts of Vault has four important pieces. As you can see here, the first is the secret engine. The secret engine is nothing but where the secrets are stored or generated, which can be either static, which is KV engine, which is key value pair, or it can be through the database, which can generate the dynamic secrets, or it can be something. There are like there are some secret engines in the HashiCorp world. And then the second piece is about the authentication. As I explained you through this diagram, you have seen that the authentication, how exactly it works, whether the enabling the auth method through the OIDC or through it can be app role or it can be something like Kubernetes, application to application. And coming to the policies, it has the fine-grained policies. It does that by defaultly denying all the access to all the users. So we have to explicitly enable the access for the particular user or particular group or particular secret engine path by defining each and every policy or every resource we're defining into the policy level. And it is coming to the token. So token is a key where it needs to authenticate the username or password, or it can be anything with the app role ID or secret ID. So tokens are basically it has the identity to give the vault the authentication process. So this is the high level architecture which I explained you for the vault. I hope you get a better understanding here. And like it is like a better understanding to how exactly we were gonna implement in this series. And the real world usages we were doing here is with this vault, uh, like application fetching database credentials dynamically, and then microservices securely accessing the APIs and encrypting the sensitive data, and the final case is which is like managing the secrets in Kubernetes. I hope so. Today you understood why secret management matters, what problem Vault solves, and how Vault works at high level. In the next video, we will install Vault and run it locally. And trust me, that's where the real hands-on begins.